Welcome to quiz 2 and its solutions. It includes extrema, inflection points, and graph sketching. Enjoy the quiz. First question in this quiz is as follows. At which value of t the function 2t divided by t squared plus 1 has extreme values? Here are the possible answers. One of them will be the correct answer. So let's search for the correct answer. To do that, first our function f of t is equal to twice t divided by t squared plus 1 implies f prime of t, which is a derivative, is pretty much this is the quotient rule, and in the end we summarize that, or the derivative to be equal to 2 minus 2t squared divided by t squared plus 1 all square. Now we have to equate the derivative to 0 so that we figure out the critical points. This implies that t equal to plus or minus 1, and f of t has two extrema, one at t equal to 1 and the other at t equal to negative 1. So if we evaluate to the left of 1 f prime of 0, we will figure out that that will be equal to 2. That means it is a plus. And then f prime of 1 obviously has to be 0. And then to the right of f prime of 1, there is f prime of 2, and its value is negative. So we have a plus, 0, and minus. This implies that at t equal to 1, f of t has an absolute maxima. Similarly, we take a look at f prime of negative 2, and that's going to be equal to a value less than 0, and it is less than f prime of 1, and f prime of 1 is less than f prime of 0, and that leads us to negative 0 and plus. This implies that at t equal to negative 1, f of t has an absolute minimum. So the answer for this is C. So C is the correct answer. Question. Find the location of the local minima and maxima for the given table, which is this table. Here are the possible answers, and we have to figure out one of them has the correct answer, and there is exactly one that is the correct answer. So let's go for it. When f double prime of a certain value of x is less than 0, over here we're calling it a, and f prime of a equal to 0, then the function concaves down. Thus we can say that the function has a maximum at the point x equal to a. Similarly, when f double prime of another point b is greater than 0 and f prime of b is equal to 0, then the function concaves up. Thus f of x has a minimum at x equals to b. Now we will just go ahead, and from the table we can see that the table shows that f prime of x equal to 0 at x equal to negative 2 and x equal to 0 and x equal to 3. So these are possible extrema. Thus we will check f double prime for each of them. So to start with, f double prime of negative 2. F double prime of negative 2 is greater than 0. F of x concaves up and has an absolute minimum at x equal to negative 2. F double prime of 0 equal to 0, f of x has inflection point at x equal to 0 because the sign of f double prime changes. It's negative before 0 and then it's positive after 0. So the point of inflection, this is a point of inflection. F double prime of 3 equal to 0. F of x has no inflection point at x equal to 3 because the sign of the function f double prime does not change. The function passes through the point but does not change the sign. So this is not an inflection point. However, f prime shows x equal to 3 as a local maxima because its sign changes as follows. Anytime we have the sign of the first derivative as plus and then we pass by the critical point and then it becomes negative, then this is an absolute maximum. So the answer will then be the first choice, which is A. So A says that we have here a minimum at x equal to -2, a maximum at x equal to 3, and an inflection point at x equal to 0. And that ends this question. For this question, we have the function f of x equal to 3x to the power 4 minus 4x to the power 3 minus 12x squared plus 12. We're supposed to find the absolute maximum and absolute minimum on the interval between -1 to 3, the closed interval. These are the possible answers and we'll be looking for the correct one among them. Here is f of x and here is a derivative of f of x. Then to find the critical point we have to equate the derivative to 0. So 12x, we take it as a factor, so 12x, and we will be left with x squared minus x minus 2 equal to 0, and this implies that there are 3 critical points: x equal to 0, x equal to -1, and x equals to 2. To find the extrema, we first get the second derivative of the function, so that's equal to 36x squared minus 24x minus 24. Because f double prime evaluated as 0 will give us -24, then f of x has absolute maximum at x equal to 0. When we evaluate f double prime at -1, we will get 36 minus 24 minus 24, which is equal to minus 12. It's negative. It implies f of x has an absolute maximum at x equal to -1. When we evaluate f double prime at 2, that will lead us to 72, which is greater than 0, implies that f of x has an absolute minimum at x equals to 0. Therefore, f of x has maxima at x equal to 0 and x equal to -1, and it has absolute minimum at x equals to 3. And the correct answer is therefore answer B, where answer B states that absolute maximum at x equal to 0 and absolute minimum at x equal to 2. It didn't mention the third one, but that is fine. That's it for this one. Let's go to the question is as follows. For the function 3x to the power 4 minus 4x to the power 3 minus 12x squared plus 12, find the absolute maximum and absolute minimum on the closed interval between -1 and 3. These are the possible answers. So let's get going with the solution. Here is the function, and its derivative obviously is 12 x to the power 3 minus 12 square minus 24 x. To find the critical point, we have to equate f prime of x to 0. And here it is. We can take as common factor 12x. So we will be having 12x multiplied by x squared minus x minus 2 equal to 0. This implies that we have three critical points: x equal to 0, which is this one. We'll end up getting the whole thing equal to 0, or x equal to -1, and also x equal to +2. These are the three possible critical points, and we need to analyze them. To find the extremas, we have to do the second derivative. So the second derivative of this function is 36x squared minus 24x minus 24. Then if we evaluate for x equal to 0, f double prime, we will get -24. So that implies that f of x has absolute maximum at x equal to 0. If we do the same for -1, we will get a negative value. That implies that f of x has an absolute maximum value at x equal to -1. If we apply the same for 2, we will get the second derivative value at 2. It will lead us to 72, which is greater than 0. It also implies that f of x has an absolute minimum at x equals to 2. Therefore, f of x has maximum at x equals to 0 and x equal to -1, and it has absolute minimum at x equal to 2. Here the options is giving just two answers, but the best answer, the best match is actually right there, which is B. So B is the best answer. The next question is as follows. Sketch the graph of the function x squared plus 2x plus 3. Since f of x is polynomial function with degree 2, let's start with a parabola with the characteristic p of 0 equal to 0. Our function is x squared plus 2x plus 3. We can rewrite it as follows: x squared plus 2x plus 1 plus 2. And then the first three terms we can group them in this square bracket plus 1. But then the square bracket, we're going to change it to this parenthesis, so x plus 1 all square plus 1. Thus, let g of x equal to x to the power 2. And we can see that g of x satisfies the condition that we put over here, which is p of 0 should be equal to 0. So here g of 0 is equal to 0. Thus, the graph of g of x is shown on the left hand side. So it's easy. That's just the graph of the parabola, which satisfies g of x equal to x squared. Now let's go to the next step. In the next step, we're going to introduce a function h of x, which is equal to g of x plus 1 instead of g of x. And when we add 1, that means we want to switch the parabola to the left by 1. So the graph of h of x equal to x plus 1 squared is shown in the middle, which is right here. Like we said, we just take this graph and shift it to the left 1 point, and that's why its center now is at 1. -1, not at 0. So this is the middle graph. Let's take a look at the next. Okay, it then follows that f of x equal to h of x plus 1. This is h of x plus 1. That means we want to shift it up by 1. The graph of f of x equal to h of x plus 1 equals to x plus 1 all square plus 1, and is on the right hand side, the graph that represents this, which is the graph that we're looking for. We can see that this graph, number 1, it was shifted to the left, so it's at x equal to -1, and then it's added 1. So instead of in the x-axis, it is 1 up, and obviously it is 1 to the left shift, and that's the graph of this. It's better that we do it this way than trying to make a table for these 3 terms and then calculate. This is a much faster way. Let's go to the next question. Is the last one, and that's why it is true or false. So if the closed interval from -pi to pi, the domain for the function f of x equal to sine, and also the function g of x equal to cosine x. Answer the following questions using true or false. Here is pretty much the graph between -pi and +pi. In blue is the graph of sine x, and is brown is a graph of cosine x. So let's get the answers to the questions. The first question is, there are 2 angles for which f of x equal to g of x, and the answer is true, because this is the first angle, which is pi over 4, and this is the second angle, which is -pi over 4. So the first is true. The second question, it says f of x is the inverse of g of x, which is not true. I mean, it's obvious from the drawing here. The curve, this curve is not the inverse of this curve. No question. So that's false. The next question is, f of x has 1 inflection point and g of x has 1. Let's take a look at the inflection point. F of 1 is the blue, and true. The blue has inflection point right here, and it's 0 for x, 0 for y. So it has 1. But when it comes to the brown one, the brown one has an inflection on this and inflection on this side. So the answer is false. It's true only for f of x, but it's false for g of x, because g of x has 2 inflection points. The next, f of x has 2 maxima and 2 minima, and the answer to that is yes, it has 2 maxima. It has an absolute maxima, and it has a local maxima, which is an endpoint. So these are 2, and it has minima also, and the minima for it is just right here. That's the only absolute minima over here, but also it has a local minima at this point. So the answer is yes. G of x has 1 maximum and 2 minima, and the answer is true. G of x is in brown. This is the only maxima, and this is the minima on this end, and this is the minima on the other end. So the answer is true. Last, the value of the maxima for both functions is 1, and the value of the minima is -1. The value of the maxima, 1 is true, because over here this is cosine of 0 equal to 1, and over here this is sine of pi over 2 equal to 1. So both of them, they have the same maxima value the absolute maximum value, but the minimum is not true, because you can see that we have a minimum over here for the sine, but we have a minima over here, and we have a minima for the cosine on this one and on this one. So these are the -1 minimas, this one and this one, but this minima is not -1, it's 0. So that's why the answer for this question is false. And that's it, and enjoy your vacation, and